Joke to start the lesson off. Why was 6 scared of 7? Because 7 ate 9. You might have heard that joke, but why did 7 actually eat 9? Well, because 7 has to eat 3 squared meals a day. So, today we're going to start with the first lesson for grade 8 on this channel, which is laws of exponents. So welcome to MathSum, your summary for all your math sums. So, let's get started. So, firstly, we're going to start with a recap. So, what is actually an exponent? Well, if we have a number, for example, 3 to the power 6, then we would say that the 3, which is what you normally would have as a number, is called your base, and the number at the top you call an exponent. And you usually say 3 to the power of 6. Cool. So, this lesson is not about just exponents, but also the law of exponents. So as you can see here, there's 3 basic laws that you need to have in your memory so that you can apply them to any problem that uses exponents. And the first one is going to be a to the power of n times a to the power n equals a to the power m plus n. So I'll just briefly go over why this is true so you can actually understand why this formula is true. So let's say we have 3 to the power of 2 times 3 to the power 3. Okay, so now this would actually be equal to 3 to the power 5, which is 3 to the power of 2 plus 3. However, this is actually also equal to 3 times 3, and that's 2 3's, times 3 times 3 times 3, and that's 3 3's. So as you can see here, there's 2 3's here, and there's 3 3's here. So in total, there's 5 3's. And that's why this will equal 3 to the power 5. So when you say a to the power m times a to the power n equals a to the power m plus n. But what's very important to note about this is that when we use this law, both numbers have to have the same base. So a to the power m times a to the power n. So both have a, and that equals a. So what a lot of students would do early on, they would make a very simple mistake, which is quite wrong. So, for example, if you have, let's say, 2 to the power of 3 times 3 to the power 4. Some students would say the answer to this is 6 to the power 7. However, this is wrong. There's 2 reasons why this is wrong. The first reason is that you got the law of exponents right. So that is right. The law of exponents gives you 7. However, the bases, these 2 bases are not the same, right? 2 and 3, they're not equal, so you can't actually multiply them. And the next thing you got wrong is a 6. So it's not equal to 6. So this problem is wrong. What's very important is that both numbers must have the same base, as you can see here. Moving on to the second one. So the second law says a to the power of m divided by a to the power of n equals a to the power of m minus n. Okay. So as you can see here, this is very similar to the first one. It's pretty much the opposite. Instead of saying a to the power m times a to the power n, say a to the power of m divided by n to the power of n. And you add the exponents in the first one while you subtract the exponents from the second one. This is pretty much the opposite. And the third one, it's a bit more trickier. It's a to the power of m in brackets. So in brackets are very important this to understand, because sometimes they will put brackets and you won't know what to do. But if you have a brackets to the power of n, that equals just a to the power of m times n. So again, I'll try to show you why this is true. So let's say we have 3 cubed, and that's squared, then that equals to 3 times 3 times 3, okay, and that's one group of 3 times 3 times 3 times 3, and that's a second group of 3. Okay, so in total we have 6 two groups of 3, so 2 times 3. Okay, and that's why that's multiplication. So moving on. Now that's the law of exponents. Now let's get on to some tricky questions that in exams a lot of students would kind of struggle or just get confused by this. So as you can see here, there's power zeros, there's brackets, there's square roots and cube roots. But I'll explain each of these questions so that you can understand how to solve it. So let's go on. First question. The first question says, so what is the difference between minus 4 to the power 0 versus in brackets it's minus 4 to the power 0? Okay, so if we look at question 1, minus 4 to the power 0. Now think of this, because there's no brackets, try adding almost like an invisible bracket around the 4. So it's like the 0 is only going to the 4. Okay, so the minus it's only being applied after it's 4 to the power 0. So it's minus 4 to the power 0, which is equal to minus 1. Okay, that's the 1 versus now it's in bracket minus 4, and that's 2 to the power 0. Okay, now the difference is this is the brackets. The 0 is being applied to the whole bracket, so that whole bracket here, this whole thing is being applied to, which means that it would just equal simply 1. If you confuse with to the power 0, here it says, I put up here, a to the power 0 equals 1, where a is anything. So anything to the power 0 always equal to 1. Moving on to the second one. So the second one is very similar to the first one, except until we don't have a minus sign. So what about 3 times a to the power 0? Again, we are going to do a similar thing. We're going to try to put an invisible bracket, like here on the a. We know that the 0 is only going to the a. Okay, so it will be 3 times whatever a to the power 0 is. And we know that a to the power 0 is 1, so it will be 3 times 1. And that gives you 3. Okay, versus the other case, again, it's very similar, 3a, but now 3a, the whole term 3a is to the power 0. Okay, now because this whole term is to the power 0, again, that 0 applies to the whole bracket, so here, that whole thing is to the power 0, and that equals 1. So as you can see, they give two different answers. This one, the first question 1, minus 1 versus 1. The question 2 is 3 versus 1. Okay, cool. You can pause the video anytime if you want to check how I got there much slower. Feel free to pause the video. Now let's go into the third one. So the third one, there is a law that I kind of skipped over, but it's right here on the top right. And this rule is here. So when you have, as you can see here, there's square roots. So we have, but ignore this so long. Don't ignore this so long. Let's look at question 3 first. Okay, so let's say we have the square root of 3 times 3. Okay. Now what you do is we can simplify this as 3 squared because it's 3 repeated twice. Okay. Now, what is the square root? Well, think of the square root here as like an invisible 2 here. Okay. Because you know it's a number times itself, so that number is repeated twice. So think of that invisible 2 here. You can even write it on the exam paper if you have it, and then what you can do is you can almost cancel them out. The square root, cancel the square root and the 2, and you left with 3. Okay, you can do the same with 5 cubed, or with the second example. So 5 times 5 times 5. And that equals, we can simplify it as the cube root of 5 cubed. Okay, again we can cancel the 3 and the 3, and we're left with 5. Now it's not actually cancelling, but what is actually happening is this rule. When you have an n here, right, which is our 2, and we have an m here, which is our 2 here, then it simplifies to m over n, so 2 divided by 2. So actually what's happening is the 2 divided by 2. Similarly here, we have cube root of 5 cubed. So it's actually a 3 over 3. Okay, so let's see if that actually makes sense. Let's see with the cube root of 5 to the power 6. Cube root of 5 to the power 6, using this rule, we have 5 to the power of 6 over 3. Okay, and this is the whole exponent, 6 over 3, which is equal to 5 squared, which is 25. Okay, so as you can see, it will be 6, which is the exponent, over 3, and that's like the cube root. If it was the fourth root, you would say the power 4. Okay, cool. So moving on. Now we have one last trick, which is actually really useful in exponents, and that's prime factorize. Okay, so remember when we were talking about what not to do when you say, let's say 2 squared times 3 cubed, you can't say 2 times 3. Well, that's exactly what prime factorize. That will help you kind of organize what can you multiply together with the same base and what can't you. So we're going to start with some examples, because examples will allow us to kind of see how to use prime factorization. So for the first example, 4 cubed times 8 squared. Now as you can see, the law of exponents says that the base has to be the same. However, as you can see here, 4, which is the base, and 8 is not the same. But if you prime factorize, what we're going to do is we're going to prime factorize 4, not 4 cubed, we're going to prime factorize 4, and we're going to prime factorize 8. Okay, so 4 equals 2 squared. Okay, and you cube that. So imagine, yeah, you're replacing the 4 with 2 squared, and you're cubing that still because there's still a 3. And 8 you're replacing with 2 cubed, which is the factorized form of 8. And you're squaring that. Good. Now, once you prime factorize it, you should notice that there's a 2 here and there's a 2 here. Okay, but we still have to do one more step. So we're going to have to use our third law of exponents, which is that 2 will be 2 to the power of 6 times 2 to the power 6. Okay, and now we have, as you notice, we have both our numbers have base 2. At first we had both, one has base 4 and one has base 8. Now we have both of them have base 2. And that can just equal 2 to the power 12. Okay, good. So that's the answer for the first question. Now the second question is getting a bit tougher. A cube root of 72 times 24. So our first step, 72 and 24, we can't really, we know we want to kind of form something to power 3 to cancel the cube root. But let's just ignore the cube root for now. So let's first look at 72 and 24. Let's try to prime factorize them, because they're pretty big numbers. Whenever you get a big number, you really want to prime factorize. So 72 equals 2 cubed times 3 squared, 8 times 9. Okay, if you don't know how to prime factor, if it's a very big number, you can use the ladder method, where you have almost like a ladder, and you have 72, and you say what goes into 72? 2. So now you say 72 divided by 2 is 36. What goes in 36? 2. 36 divided by 2 is 18. What goes into 18? 2. 18 divided by 2 is 9. What goes to 9? 2 doesn't go to 9. Let's look at 3. 3 goes to 9. That's 3. And you can do that until you get to 1. And as you can see, the prime factorization is here. 2 times 2 times 2 times 3 times 3, which is 2 cubed times 3 squared. Okay, and then moving on, 24 equals 2 cubed times 3. Good. So now we have that this cube root of 72 times 24 equals the cube root of 2 cubed times 3 squared times 2 cubed times 3, which equals to the cube root of 2 to the power 6 times 3 cubed. Okay, as you can see, we highlight this. So we have 2 here and a 2 here, which is the 2 there. So 2 cubed times 2 cubed. And we have a 3 squared times a 3, which is a 3 cubed. As you can see, there will be a 1 there. So 2 plus 1 is 3. Cool. So, where does that leave us with the answer? So I'll raise the top one here. So then the answer will, okay, so we first have to simplify it, equals to cube root of, so now what we want to do is we're going to say 2 to the power of 6 over 3, as you saw from the other rule, times 3 to the power of 3 over 3. Okay, because if you take note, 3 here, 3 here, 3 here, and the 3 here. That's the cube root. Okay, and the 6 comes from here. The 6 here, and the 3 comes from here. Okay, and that equals, after a long chase, that equals 2 squared times 3, which equals 12. Okay, that's question 2. That's quite long, but as you can see, you must just follow the steps step by step, and you prime factorize it, add up the exponents, and then after you add up the exponents, then you use the cube root of that, and you use. So as you can see, pretty much every law will be used. Even more multiple laws will be used on the same question. So let's look at question 3. Question 3 might be looking scary to you guys, because we have this strange thing, the m. Now, yeah, m will be part of algebra, but just think of it, don't be scared of m, because just think of that as just another number. If we had 2 times 3, or let's say 2 times 5, and 3 times 5 squared. So that's just pretty much another number. So don't be scared of that. So let's try looking this step by step. So 2m to the power 5, which equals 32 times m to the power 5. So we look at each exponent, times, okay, 3 squared. So this is the one term, times m to the power 4. Okay, we look at 2 times 2, and this is the 1 times 5. Okay, now we want to look at similarly terms of the same base. So actually 32 and 3 squared, yeah, that's just a constant term, so we can just times them together, 32 and 3 squared, and m has the same base. So just know that m has the same base, so we can times them together. So 32 times 9, 32 times 9 times m to the power 9. Okay, and that will be whatever the answer for that is. But yeah, pretty much that's the principle of it. So that will be our last exercise for the lesson. However, I have some other practice problems that test all these new laws of exponents that you just learned, and the answers for these will be in the description of the video. So if you guys have any questions on any of these practice questions, please drop a comment down below, and I'll see you in the next lesson. Bye.